Now this is a question, A-level question about asymmetric encryption, but we'll just add a bit to it about the general idea of encryption, asymmetric encryption. So we've got two people. We've got computer A and computer B. Now you sometimes hear this described as Alice and Bob because they often use the names Alice and Bob to talk about encryption. So computer A, or Alice, has got B's public key and their own private key here. So they're holding that. So that means that B has given their public key to A at some stage, and B's also got A's public key and their own private key. So when A sends the message over there to B, the encryption is going to be done using B's public key, and then the data is sent over and it can be decrypted using B's private key, because the whole process is a one-way mathematical function that needs the private key to be able to successfully decrypt it. So they can use their private key to do that. So it doesn't ask you about that in this question. It talks about how B will decrypt the message and verify that it was sent by computer A. So they're talking there about creating essentially a digital signature. So B's private key is used to decrypt the message. So we already said that. So we can say that B uses its own private key to decrypt. And it's going to decrypt both the message and the signature doing that. So the message and the signature. So in order to decide whether this message actually came from A, as it suggests, i.e. verify the digital signal, then we need to create a new message digest or a hash. So we then calculate a digest from the message, and then we use A's public key to decrypt the digital signature. And once we've done that, we should be able to compare the calculated digest that we had here. So we've just calculated a digest. And when we decrypt it, we can compare the two. Compare to the calculated digest. Sometimes these are called hashes as well. So it's a hash or a digest. So compare the two, and if the recalculated digest here is the same as the one that we've just decrypted, then we know that the messages match, and so the digital signature is a correct digital signature, and we know that the message came from the person who wrote that signature, so computer A in this case. So this is just a case of whether the received message and the recalculated message digest can match each other. So if both of these hashes or both of the digests match, then it's going to be the correct digital signature. So that's enough to get the marks on the question that we had there. So explaining how computer B decrypts the message. So we've explained that it decrypts the message using its own private key, and referring to specific keys, so we've said which key is going to be used. It didn't ask us to do the bit where we talked about the encryption there, but it just helps to see how that works. And then this idea of creating a digest, again, we calculate a new digest or a new hash from the message, and then we use A's public key that we already hold to decrypt the digital signature, and then compare the calculated digest with the decrypted digital signature. And if they're the same, then it's correct and it came from computer A. So just a few bits about the idea of asymmetric encryption and specifically how to answer that particular question, which I think that question was worth 4 marks, I think.